Hello and welcome back. I'm Matthew, the C# artisan, and this is the second video in my series on Azure Service Bus. Today, before we dig into the actual code, I did want to spend just a little more time talking about theory. And I want to ask the question, what exactly is a queuing technology for? Why would you use queues? Now, you may have heard people say, well, the purpose of queues is to decouple the components of a complex system or implement a message-based architecture, and all of that is true. That is exactly right. It's still a little abstract. So I thought I'd have a little fun with this and kind of walk through some concrete examples that maybe will give you a better mental model for exactly how queues work. So this is my friend, and this is a vending machine. And I think she's feeling a little hungry. So she's going to walk up here to the vending machine, and she's going to order some chips. So how does that go? Okay. So the first thing is she is going to put some money into the machine, and she's also going to make a selection. She'll put some buttons there. And after she's done, out of the machine is going to come some chips. So that's how a vending machine works. You walk up to it, you put in money, you make your selection, and you get your chips. And the key thing here is that this is kind of a single transaction. It all just happens together. So if we wanted to model this with some software, we might create a server to model the vending machine. So let's say it's a REST server that has a REST API, http://vendingmachine.com, and maybe an endpoint called order where you can place your orders. So the client, my friend, would post a message here, and maybe the JSON body would be, okay, I'm paying $1.75 and my selection is B7. So there's your input to the system. And then the server immediately returns your result payload, your result JSON. So maybe there's an order number and the order date and the product you ordered with its brand, Yummy Snacks, the item chips, and the size, 2.2 ounces. So there you go. We've ordered chips via an API. So this is the traditional way that two systems, the client system and the server system, would interact. You talk to the server and you get a result. So this is not a queued system. This is the opposite. So let's contrast this with a queued system. And here's one that we're all familiar with. A restaurant. Almost all restaurants are going to be a kind of queued system. And I don't want to just talk about any old restaurant. We're actually going to talk about one of my favorite South Indian Tamil restaurants in Plano. This is, I'm not going to pronounce it right, Madurai Tatu Kadai, which is this fantastic Indian restaurant in Plano. So here I am. And when you order your food at this restaurant, you walk up to this counter here, and there's menus and the specials written on the board, and you place your order with the friendly person behind the counter. They take your money, and your order goes into an order queue. So there were already a couple of orders in the queue, and then my order 3, goes into the queue, and then that's it, right? That's the end of the transaction. I don't immediately get my food. It hadn't been cooked yet. It doesn't even exist yet. So, normally then I go back, I sit down and I wait for the food. But the process of placing an order really is about putting something in a queue. And then there are these guys in the kitchen who process the orders, who actually roll out the dough and cook the parotas and serve up all the great food. So if we wanted to model this in terms of software, our REST API call would work in terms of placing the order. You could get back your receipt and your order confirmation, but you would not get the actual food. So for that, you have to wait. It takes a while for the food. Now, you're saying, well, I do eventually get my food, right? I hope so. It's a good restaurant. I've heard good things about it. So the process of getting the food in a restaurant is actually a second, completely separate queue. And we'll call that the pickup queue. And in this particular restaurant, there is a little counter. So after they prepare your food and plate it, they call your name and they say, Matthew, order for Matthew. And you walk up and you get your food off of the pickup queue. Now, you might be saying, well, what if there's waiters? What if, it's fine. The fact that your order might be taken by a waiter who runs it back, who then enters it in a system, and then maybe there's a runner who brings your order out, doesn't really change the overall structure. You've got an order queue and a pickup queue. And the reality is, every once in a while, somebody places an order and they leave and they never pick it up and it just sits there, right? Or, your order gets lost. I don't know, they don't process it. I don't think that happens at this restaurant, but then your food never arrives. So these two queues are completely separate processes. And here I am smiling because I've got a couple of fresh parota and some really spicy curry. So this is a real world situation where queues are actually in place. And when we're talking about writing software, we want to think about using queues to model real world situations that actually follow that kind of pattern. And so in my mind, I put it in two groups. The first is you're initiating a potentially long or complex process and you're not waiting around for the result. Doesn't mean there is no result. You're just not waiting for it. So we talked about placing an order, but what about submitting an insurance claim, right? When you submit an insurance claim, they're going to collect a bunch of information, do an investigation, and there's this whole underwriting process that happens, or I don't know if it's called underwriting. That's like applying for a mortgage. But there's a process where eventually you may or may not get, some money back from the insurance claim, and you may or may not get your rates raised. You'll see. Filing your taxes is another one, right? Whether you mail it in or e-file, you prepare all this stuff and you send this really complex message off to the IRS or whoever your tax authority is, and then they process it. And you don't sit around watching them do it, and you don't wait for your refund or whatever. You just send it. Submitting a job application, right? You can go on your favorite recruiting website, submit a job application. You may never hear back. You may never get an acknowledgement. You might get an interview. Requesting an appointment. Many systems like clinics now or doctor's offices have an online system where you can go on and you can say you'd like an appointment, and then somebody gets back to you and schedules with you. I had that happen last year with a diagnostic where they had about a 3-month waiting period. So I requested it, and then a technician called me back and scheduled. So in all of these situations, you're initiating a long process. You need to send a message into a queue, and then you need to know that your message was received, but you're not getting any result back yet. The other kind of purpose for a queue is notifying some system or someone that something happened. So for example, maybe you've got sensors out there. You've got stream flow sensors recording the runoff or the stream flow in a river, or you've got a snow melt sensor recording the depth of snow, or a rain sensor, all kinds of weather or scientific things that report periodic readings, once a minute, once a month, once a day, once an hour, who knows. And they need to simply report this. So they're going to send that message off to a queue where it gets ingested and aggregated with other data, and somebody does something with it. Filing a news report is a similar kind of thing. A reporter in the field gathers up information, files the report. That will perhaps cause it to go through editorial and get published, but really their job is just to file it. Or signaling something like a stock price change, or sending a suggestion to an electronic suggestion box, or even filing a bug report. You can go into your whatever system you're using for bug tracking and write a bug report. So a lot of these kinds of things begin with a basic post into a system through an API, but then that system puts a message in a queue saying, okay, someone entered a bug report, someone else better triage it and look at it and respond to it. So these are the real world situations you want to look out for when you want to use a queue. And you can see now, yes, it does decouple the pieces of a complex system, because the kitchen is a complex system that needs to be decoupled from the place where you take the order. Or the people sitting there processing all the taxes, that's a complex thing that's decoupled from the part that does the intake, where you file them. So that's what this whole decoupling thing is all about. This is a little more like streaming data or just posting. And often in this case, you'll have multiple subscribers, like a pub sub kind of thing, where you can file a news report, on the AP wire, and then lots of sources will pick it up. So that's a pub sub model, where you just post it out there on the queue, and because it's configured as a multi-receiver queue, lots of people can go get the message. Okay, so that's the theory of why you would want to use this technology. In the next video, we're actually going to roll up our sleeves, set up some queues, and start writing some C# code. I'll see you in a sec.